Hello all, I am Guru Prasad from Ishwari Engineering College, Chennai. First of all, thank you for giving me this internship opportunity. In this video, we are going to see the microwave oven simulation project. Before going to this project demonstration, let us recall the things that we are gone through in this internship. First, we will see what is an embedded system and what is a microprocessor and microcontroller, and what is a microwave oven and requirements to build the microwave oven, etc. Embedded system: any combination of hardware and software which are intended to do a specific task that can be called as an embedded system. For example, fire alarm is an embedded system which sends only smoke. The other examples of embedded systems are washing machine, microwave oven, smartwatches, etc. A general purpose system is used to perform for a large number of tasks, whereas embedded system is used to perform for a specific task. Categories of embedded system. First, we will see real-time embedded system. It gives the output in a specific time, so it basically follows deadlines to complete the task. In real-time embedded system, it is classified into three types: hard real-time, firm real-time, and soft real-time. Hard real-time: if the result is obtained after the deadline, the system is considered to have failed completely and it is a life critical. For example, pacemaker, autopilot system, etc. Firm real-time: it is similar to the hard real-time, but it is not life critical. For example, moon rover, satellite-based tracking, etc. Soft real-time: if the result is obtained after the deadline, the system is considered to be successful. For example, ATM, mobile communication, airbag system, etc. Network system: it is related to the network interface so that it can be either in local area network or wide area network. For example, home security system. Mobile system: this system which are movable are called as a mobile system. For example, cell phone, etc. Next we see how to choose an embedded system. An embedded system should be in low power consumption, cost efficiency, efficient use of processing power, it should be reliability, and efficient use of memory. Microcontroller: it is a small and a low-cost microcomputer which is designed to perform the specific task of embedded system, like displaying washing machine information, receiving remote signals, etc. It has a design restriction such as memory size, input-output capabilities, peripheral functions, etc. To choose a microcontroller based on its application, performance, price, availability of tools, and special capabilities. Next we see microprocessor versus microcontroller. Microcontroller: in microcontroller, all components will be in a single chip, whereas in microprocessor, all components are assembled separately. In microcontroller, it is less flexible and less design complexity. In microprocessor, it is more flexible and more design complexity. In microcontroller, it consists of 14 port pin, RAM, edit and create microprocessor, program memory, and CPU. Whereas in microprocessor, it consists of ALU, input device, control unit, output device, register array, and memory. As we discussed in the previous slide, in microcontroller, all the components are embedded in a single chip, whereas in microprocessor, all the components are assembled separately. Next we see what is microwave oven. Microwave oven is an embedded system that heats and cooks food by exposing it to a electromagnetic radiation in the microwave frequency range. There are several modes in a various microwave oven. In this project, we are going to implement 4 modes: micro mode, grill mode, convection mode and start mode. Micro mode. This mode is used to cook food in a traditional way. In micro mode, the maximum power of use is 900 watts. In this, maximum time that you set for cooking is 60 minutes. Grill mode. This mode is used to cook meat and bread. It works as a micro mode, but the purpose of to cook the meat and bread. User can set time as per the cooking time of the meat. Convection mode. In this mode, user can set the oven to preheat for a particular temperature, and it takes 3 minutes to preheat the oven. After preheating is done, then the user can set the time as per the requirements.
Hello, my name is Ali Muhammad. Now we are going to see what are the requirements for microwave oven project. First, we should have a basic knowledge in embedded C programming, so that only we are able to write a program for that. Next, MPLABXIDE XC8 compiler. In that compiler only we are going to run the C program, PICSimLab. In that lab only we are going to simulate the microwave oven simulation. PIC16F877A is a microcontroller we are using in our project. 16x4 CLCD display we are using in the project. Tactical switch is used to change the mode and number of mode in our project. Matrix keypad for entering the input data. Timers play a major role in our project. Now we are going to see how other components are connected to the PIC16F877A. First, we are going to see about GPIO, which is nothing but a general purpose input output. It is used to handle both output and input digital signal, and it is used as a bidirectional pin. Next, A2C, which means integrated circuit. It is a bus interface connection protocol incorporated in a device for serial communication. It uses either RTC and EEPROM to store the data. It is also a bidirectional pin. Next, LM35 temperature sensor is nothing but a linear model 35 temperature sensor. Is a temperature measuring device having an analog output voltage proportional to the temperature. It provides output in Celsius. It is also unidirectional. Next, ADC, which is nothing but an analog to digital converter. Next, RS232. It stands for Recommended Standard 232, and it's a type of serial communication used for transmission of data, and it is bidirectional. Next, LEDs, light emitting diode for the indication purpose. Buzzer is an audio signaling device used for the same indication purpose. And alarm. Next, digital keypad for entering the value of oven, timing, and other modes of operation. Next, SSDs, solid state drive that use an integrated circuit to store the data like our C program in our simulation. Next, matrix keypad, which is similar to a digital keypad. Instead of digital, it uses old row and column method to enter the data. At last, CLCD display to show the information. Now we are going to see deeply about CLCD display. CLCD display is nothing for character liquid crystal display, which has similar features like liquid crystal display. In PICSimLab, there are two types of display: 16x2 display, 16x4 display. A 16x2 LCD means it can display 16 characters per line, and there are two such lines. Whereas in a 16x4 LCD, it can display 4 characters per line, and there are 4 such lines. Now, in this project, we are using only 16x4 characters. In this picture, you can easily learn that how it works and what are the features in that, like for data display FDC1604 series for data LCD module. It displays the ASCII character and some special characters also. It is the most commonly used display in lot of projects. Two types of communication modes are there in this LCD display, that is 4-bit mode and 8-bit mode. 4-bit mode means it can store up to 32 bytes of memory, whereas in 8-bit mode it can store up to 64 bytes of memory. Next, tactile switch. Tactile switch is a switch whose operation is perceptible by touch. This switch is used to select the mode of operation and to enter the temperature and enter the time in our project. This switch will produce a bouncing effect when a switch is pressed. Bouncing effect nothing but the element move quick up, back or away from the surface after touching is called bouncing effect. In this picture you can see a metal plate. When we press the switch from the top, the metal plate will make contact with the terminal. Now it becomes a closed circuit. Then the current will flow through that. Like that, the readings will change and above. Next, matrix keypad. Matrix keypad is a keypad in which the number of tactile switches are connected in row and column concept. This is used when more number of user inputs are required and still want to save some control input-output lines. The basic principle on a matrix keypad is it repeatedly scans the keypad one column at a time. It sets the column to low. It then checks each row in the column for a low, which indicates a key press. These keypads are most commonly used in telephones, calculator, digital lockers, etc. Now we are going to see about interrupts. What is interrupt? Interrupt is a communication process set up in a microprocessor or microcontroller in which an internal or external device requests the microprocessor unit or microcontroller unit to stop the processing. Then the microprocessor unit or microcontroller unit acknowledges the request and attends to the request. Then go back to the processing where it was interrupted. In simple word, we can say that interrupt or external signal that can cause the CPU to handle specific events such as hardware device requesting attention. In physical interrupt means timers. In software interrupt means we can use a program called delay. Next, we are seeing about polling. It is a process where a computer or a controlling device waits for an external device to check the readiness or state, often with a low-level hardware. For example, when a printer is connected via parallel port, the computer waits until the printer has received the next character. The process can be a minute as only reading one bit. Next, interrupt service routine. Interrupt service routine, also called as interrupt handler, is a special block of code associated with a specific interrupt condition. An interrupt is a software routine that hardware invokes in response to an interrupt. Interrupt service routine attends to the request of an interrupting source by clearing the interrupt flag and should save register content that may be affected by the code in the interrupt service routine. It must be terminated with instruction RETA, which means re-timed. When the interrupt occurs, the microprocessor unit completes the instruction being executed, then it displays global interrupt enable, places that address on the program counter on the stack. Next is timers. Timer is an important application in any embedded system, which is a default peripheral which maintains the timing of an operation in a synchronous with a steam clock or an external clock. This microcontroller has three types of timer. There are timer 0, timer 1 and timer 2. In this project we are using only timer 2. It has many applications such as measuring time, generating delay, etc. Timer, or also called as counter, is a software designed to count the time intervals between the event. Resolution, which is also called register with, there will be 8-bit or 16-bit, etc. Next, tick. Tick is referred as a change from one number to another number. It may be up count or down count. The tick function records the current time. Quantum, which depends upon the system clock setting, is measure of time which is responsible for tick. Scaling may be pre-scalar or post-scalar. The scaling ratio 1:2 means that the clock has to have a low to high transition twice so that the output of the prescaler completes one high pulse. Here is the block diagram of a timer. First, the oscillator will generate a signal that will go to the clock select. For this, they will select the clock signal, then it goes to a prescaler like a 1 is to 1 ratio or 1 is to 8, like that it will go in any ratio. Then it goes to time disabled. In that, time will be disabled for specific time. Then it will go to the time count and overflow. Last, it will go to the interrupt enabler, which enables the timer. Next, simulation of a microwave oven will be explained by our teammate Abhijit Raj.
Hi all, I'm Abhijit Raj. I'm going to show a project demo of microwave oven. I have loaded my X file. Now you can see that there are four modes: micro, grill, convention and start. When I click one, it will auto select micro mode. When I click two, it will select the convention mode. Same for third and fourth mode. When it starts, the coolant starts running. Then when it turned off, the heater will be started and then the buzzer will start. So now you can see the power is equal to 900 watts. It asks us to enter the time. I'm entering it with hash. I set it for 5 seconds. Now the cooking time is up. Now let us check the second mode, grill mode. It is used for toast and grilling. For this also, I'm entering 5 seconds. For convenience, it starts. Now the cooking time is up. Now I'm moving to convention mode. Here we must set the temperature. I'm giving it as 123 degrees Celsius, entering it with the hash. The remaining time is 1677, 176 and so on. Now you can see the display 1, 2 and 3 is turned off. Now you can opt for LCD. These tactile switches connected in rows and column manner. This is a microcontroller. The time remaining is nearly 140 seconds. Now the time remaining is near 120 seconds. Let us wait until it reaches 0. Now I am maximizing it. Now it's nearing 70 seconds. These are the RB3, RB4, RB5 switches, as my friend explained. Only 50 seconds left more. Let us wait. Okay, now it's nearing 5, 4, 3, 2, 1, and the remaining time comes 0. Now it asks us to set time. Setting some 20 seconds. Now it comes, we have 4, 5 and 6th option. 4th is start or resume option, 5th is pause, and 6th is stop. When I press 6 it stops, cooler and heater. Now I'm entering 4th, the microcontroller starts and resumes. When 5 is, it pauses the operation. Here the door status is open. Now I press 6. Now when I press the 4th option, it goes to start. Pressing 4, the time starts with 30 seconds. By again clicking it incremented to some 53 seconds. Here the cooler's temperature is somewhat about 27.50 degrees Celsius. And this is our project. Thank you Emertxe Technologies for this wonderful internship opportunity. We have gained more knowledge about embedded systems. Thank you. Let us wait till the cooking time is up. The cooking time is up, and thank you so much. This is all about our project.